Our objectives for today's class is to define the subject of physics, to review the steps of scientific method, because I'm sure by now you took at least biology and you did study the steps of scientific method in details. And the last objective will be to identify units of fundamental physics quantities in international system of measurements. So, what is the subject of physics? To come up and to understand the subject of physics, I wanted to observe this beautiful scenery. And this is a bigger picture. And I wanted to come up with two questions that you think will appropriate to ask a physicist. And you probably need to take a minute or two to think about it and observe the picture. So you can pause, and I wanted to write down those questions in your notebook and share with your class and discuss. And after that, come back to the recording. So please observe the picture and come up with two questions that you think will be appropriate to ask a physicist to get a professional answer. Okay, I think some of the questions that can be on your list are why is the grass green? Why is the sky blue? Why does airplane leave a mark in the sky? How does a dog right here flow? So these are type of questions, and if you look through the list of my questions or through your list, you might notice one common thing, that they're all related to what is called inanimate nature, inanimate phenomena, inanimate phenomena. So inanimate phenomena, it's a phenomena related to non-living thing. So sky, grass, okay? The question about dog, but it's about how does it flow. So it can be a stone or it can be a boat. So we are concentrating our attention on floating, not on the dog. So the physics is a study. Physics is a study of matter and energy and their interaction. For example, grass is the matter. Their sunlight is an energy. So the result of the interaction is the color of the grass. The same atmosphere that seems invisible here is the matter, and light is an energy. The result of the interaction is the color in the sky. So that's to understand physics, it means to understand the rules by which nature plays, which means to understand the interaction between matter and energy. So the major characteristics of any matter are mass and volume. And the major characteristics of energy, unlike matter, energy does not take space and it doesn't have mass, but energy makes things move. Mass, for matter it's mass and volume, which is space. And for energy, one of the major characteristics is to make things move. So this year we mostly will study mechanical interaction, and everything that is in motion, airplane, a dog, it will have a speeds that are much less than the speed of light. But you can see that the nature is very complicated. So there are different areas of physics that study different parts of nature. And you can find on page 3 in the textbook that we will be using this year, the scope of physics, which includes mechanics, thermodynamics, of electromagnetism, optics, and modern physics. So please take a moment and think about examples of natural phenomena that is going to be inanimated phenomena that will be subject of each of these areas. You probably want to pause to discuss it. Okay, probably you come up with examples of thunderstorm, which will be a subject to study in electromagnetism as lightning. So the colors on this picture will be subject of optics. Okay, the temperature of the atmosphere or water will be the subject of thermodynamics. And so modern physics, it's hard to see it on this picture, so it's related to nuclear physics, and it's related to particles that are moving with the speeds that are higher than the speed of light. Or not higher, I'm sorry, that are about the speed of light. So the speed of light is the maximum speed that it's possible. So far. Okay, so what is the subject of physics? Please review. Okay, to understand the rules by which nature plays, we have scientists use scientific method. So scientific method is a series of steps that it's taking to solve the problems. So the first step of scientific method will be the same one as we did today. So observation, problem, and the result of observation is always a question. So probably when you were a kid, you had a lot of questions about nature because you have done a lot of observations. So the first step is observation, and the result of the observation is a question. Observation, and the result is a question. And then we try to answer this question, and we do formalize a hypothesis, which is a testable prediction. Testable prediction. So to check the hypothesis, we have to do the experiment. And it's important to remember that each experiment can have only one variable. So which means we can change only one physics quantity during experiment to see what changes it will produce to the whole system. Based on the experimental data, we can make a conclusion. And conclusion either going to support and prove the hypothesis, and then we can formulate a physics law, or it will deny the hypothesis, and then we need to come up with new testable prediction, new experiment, and make a conclusion based on new experimental data. So the physics law is a rule of nature, and it establishes the relationship between different physics quantities. So what is scientific method and what are the major steps? Please tell each other. And maybe come up with an example of the problem in life that you solved and actually use the step of scientific method. So to make an experiment is an important part of physics, and if the theory or law hasn't been proved by experiment, so it's not being established, so it has to be proven. So during experiment we have to take measurements. So when we take measurements, we have to use the same unit to communicate the same language. So any physics quantity has name, definition, numerical value, and unit. Unit is very important, it's essential, it contains so much information. For example, let's compare numbers 7 and 7. So far it looks at the lucky numbers, and 7 equals 7. But now let's say add 7 pounds and 7 miles. So can you tell now that these two quantities are equal? No, because we're talking about two different things. And the way we understand we talk about different things is unit. So it's very important to put unit after each numerical value for physics quantity. The free physics quantity that I want you to know, the units of free physics quantity I want you to know right now are length, which is distance between 2 points. Did I spell it? Okay, mass and time. So the unit, the basic unit that is established in this international system of measurements for length is a meter. The basic unit of mass is a kilogram, and the basic unit of time is a second. So there are cases when we have, the meter is about 3 feet. So if we need to express quantities that are bigger than 1 meter, we're going to use prefixes. So international system has several prefixes that expresses units that are higher or lower than the basic unit. So the prefixes are based on the power of 10, and you can find it in table 1-2 in the textbook, all the prefixes. These are the ones that you have to memorize. So the small prefixes, nano, little n, which means 10⁻⁹. So we can say nanometer, which means 10⁻⁹ of a meter. So micro, which is, this is mu, okay, pronounce it as mu, and it's 10⁻⁶. And milli, m, little m, 10⁻�3, and centi, c, which is 10⁻². So if you look for this power of tens, you might notice a common pattern. Think about it while I'm listing the prefixes for the positive quantities. So the prefixes for the positive, I'm going to write right here. Kilo, which means K is a shortcut and it's 10⁻�3. Mega, capital M, 10⁻⁶. And giga, capital G, 10⁻⁹. So we cannot use two prefixes at the same time. So kilogram, it's already a prefix kilo. If we want to use, if we need to express different units for mass, we can say gigagram. And then we'll say capital G, little g. So the common pattern that I wanted you to notice is that the power of 10 most of the time changes by 3. Exception is the centimeter. Not centimeter, sorry, centi. So what is International System of Measurements, and what does the unit show? Discuss it in class.